We want to solve the trigonometric equation cos squared theta is 2 times sin theta minus 1 for angles of theta between 0 and 360. So our equation is cos squared theta is 2 sin theta minus 1, and we can expand the bracket to give us cos squared theta is equal to 2 sin theta take away 2. We now use the fact that we know the identity sin squared theta plus cos squared theta is identical to 1. Rearranging, cos squared theta is identical to 1 minus sin squared theta. We can substitute this into here, so 1 minus sin squared theta is equal to 2 sin theta take away 2. And bringing everything to one side, we get sin squared theta plus 2 sin theta minus 3 is equal to 0. So we have a quadratic equation. We can solve this quadratic equation by factorizing into two brackets. Put a sin theta in each bracket. A 3 and a 1. And to get plus 2 sin x, this must be a plus and this must be a minus. If we look at the expansion, we'll get sin squared theta plus 3 sin theta minus sin theta gives us a 2, and then minus 3. This tells us that sin theta is equal to minus 3, and this one that sin theta is equal to 1. If we consider the graph of sin x, then the highest it ever goes to is 1, and the lowest is minus 1. The sine of theta is always between minus 1 and 1. Therefore, sin theta is minus 3 cannot be possible, and therefore this gives us no solutions. Sin theta is 1 has just the one solution, which is at 90 degrees. Sine of 90 is 1, and so therefore the only solution we get here is theta is 90 degrees.